So with this section, the big thing that you have to remember and think about is that no matter what size the circle is, the angle is not going to change. So if I look at, so with section 9.4, this is again the trig ratios continue. So if we look at no matter what the size of the circle is, the trig ratio should always be the same. So no matter what, if I have a 30-degree angle, the sine value should be 1/2. If I have a 60-degree angle, the cosine value should be 1/2, and I'm getting those numbers from right here. So if I know I have a triangle that has a 30-degree angle, no matter what happens, I can figure out the sine and cosine, no matter what the size of the circle is. Now the only issue is sometimes, like if I'm given a circle that has a unit or a ratio of 1, that's great because it's the unit circle and I'm done. If I'm given a circle that is not a unit circle, I have to be able to find a certain angle based on that, and that's how we use the ratios. So for instance, I could give you something along the lines of this. If I have an axis, so if I have an x and y axis, and basically I am given, it doesn't matter, a point somewhere in space, and that point is, let's say, like -12, -5. So -12, -5 is going to be somewhere over here, right? So this point right here is going to be the point -12, 5. So what we're really looking at here is we could kind of create a circle around this point, right? I could create a circle around this. And if I create my circle around this, this is going to be absolutely atrocious. But if I create a circle around this, basically what I've done is I've just created a unit circle.
Won't it, it's +5, so won't it be on top?
It's -5, sorry. I meant -12, -5. I was fixing that right as soon as you said it. So basically now I've just created a circle that goes through that point that is centered at the origin, and then it's going to have a radius from here to here. Now basically what the question is asking me to do is it's asking me to use this as the initial side and this as the terminal side, and tell me what this angle essentially is. That's what it's really doing, but it's not giving you that angle. So it doesn't tell you that angle. So the question would specifically say, determine the exact 6 trig function values. So I want to find the 6 trig values based on the information that it gives me. Now that being said, I need to pay attention to what the x values are and the y values are, because according to this piece of paper, if I know what the x values are and the y values are, I can create my trig values based on those ratios. Now the only thing that I really need is I need to know what the radius is, because if I can figure out what the radius is, then I'm good to go. And yesterday we had already said that we can figure out the radius by doing x² + y² = r², right? So we had already figured that part out. That was the sine value and the cosine value, and we square them and it equals the radius. It equals 1 for the unit circle. So in this one, if I want to figure out what my radius is, I just do -12 squared plus -5 squared equals whatever my radius is squared. Or if you just want to, you could skip the step and take the square root of both of those things. But now we would see that 12 squared is 144, 5 squared is 25. So I get 169 equals r². So I can find out that my radius is 13. Now, before you ask, because a lot of people are thinking this, 99.9% of the problems that you guys are going to use, not all of them, actually, I'm not even going to say that. A lot of the problems that you use are going to be Pythagorean triples. So like the questions that I give you on a test will be Pythagorean triples. So like this is a Pythagorean triple because it works nicely. Every once in a while, you're going to get things that aren't Pythagorean triples. You're going to get things that, you know, you might have to simplify. You might have to be a little nicer with using radicals and using things like that. You might have to simplify them in a different way. But in my cases, when I give you a short little quiz or a short little test, I'm going to give you ones that work out to be Pythagorean triples, just because it's going to make the numbers easier and the numbers nicer, okay? So right now I figured out that my radius is 13. So now all I need to do is use my, I just need to use my sheet that I have in front of me, and I'm good to go. I don't really have to worry about anything else. So once I find the sheet that, or the values that are in front of me, the x value, the y value, and the r value, I can just use what my sheet shows to figure out the exact 6 trig functions. Okay, so I'm going to find those exact 6 trig functions, and I'm going to use my sine of whatever the angle is. I don't know what the angle is, the cosine of an angle, and the tangent of an angle. And then I'm going to go through and find out all of the other ones. So cosecant, secant, and cotangent. Now that being said, this is where your circular trig yellow sheet is going to come in handy, because it tells you what to put where. So I have -12 as my x value. I have -5 as my y value. I know that my sine value is the same thing as y over r. So it's going to be -5 over 13. My cosine value is x over r. So -12 over over 13, not -13. I have my tangent value, which is going to be my y over x. So y over x, -5 over 12 is the same thing as 5 over 12. And then it's really nice because going from here to here, all I'm going to do is flip them. So 13 over -5. This one is going to be 13 over -12. And then this one is going to be 12 over 5. So this is how that process actually works. That's how that process actually works as we work our way through. So yesterday's process was not a great process for me to use. So don't worry about that process too much, because it was kind of a bad example, not kind of a bad example, a bad example. So just understand that that's kind of what's happening, okay? The proof that I was trying to do, or trying to show you, so is everybody good with this? Does anyone need this still? We're good? Oops, just dropped all of my papers out of my binder. Okay, so we're all good here. So now what I want to try to show you, this is kind of the proof of what I was talking about yesterday. So if I have a circle, and that circle has a radius of 2, and it has a sine value, or an angle of 30 degrees right here. This is the exact example we used yesterday. If I think about this using a triangle, and I look at this triangle like this, come on. And let me give you a little bit more information. Let's say that this side is 1. I know that the sine of 30 is equal to 1/2, right? I know that the sine of 30 is equal to 1/2. Now, that's based on my unit circle. If I look at my unit circle, I can see that 30 degrees has a sine value of 1/2. If I want to figure out the sine of any angle, all I have to do, or I should do it like this. If I want to find the sine of any angle, I just take my y value and I put that over the radius. Now, in this case, I know that my y value is 1 and my radius is 2, which I have just shown that the sine value of this, based on, even if I didn't know that angle, the sine value is 1/2, which I've basically just proved that the sine value of 30 is equal to 1/2, regardless of the size of the circle. So no matter what, regardless of the size of the circle, you just take your values, your y value and r value, and you plug whatever those values are in, and it should equal the exact same thing that you find on your unit circle, no matter what the unit circle looks like. So no matter what that unit circle looks like. So now that being said, we could also find other things too. We could go like this, and I could say, okay, if I know that this side is 2 and this side is 1, I could find the length of this side, right? I could call this x, and I could say x squared plus 1 squared equals 2 squared. So then this is going to say x squared plus 1 equals 4. So x squared equals 3. So then that means x equals the square root of 3, right? So this side length is now the square root of 3. So if I want to find the cosine of whatever angle that is, I would take the adjacent over the hypotenuse, or x over r, which is the square root of 3/2. And so I'm basically saying that the cosine of whatever this angle is the square root of 3/2. But according to this picture, that angle is 30, right? So basically I'm saying, well, if I did everything correctly, the cosine of 30 should be the square root of 3/2, which it is. If you look at the unit circle, that sine, that value is the square root of 3/2. So no matter how you find it, if you just pay attention to your ratios, and use those ratios appropriately, it should produce the exact same thing that you see on your unit circle. So if it produces the exact same thing that you see on a unit circle, you've essentially proved that the size of the circle doesn't affect the value of the trig ratio. All right, that's what I was trying to show yesterday, and I just did a really, really bad job on it. So keep that in mind. All right. Any questions on what you guys see right now? Any issues on anything that you guys see or think that would pop up that would be tough? All right. So the next thing that I want to kind of mention to you, because there are a few other things that I think are going to be an issue, and I just want to make sure that you understand how they work. So for instance, if I give you a problem that looks like this, where it's like the tangent of negative 210. Tangent of 210 degrees. If I'm asking you to find the value of this trig function, I need to try and figure out a few different things. Okay, so a few different ways that you can do this. Number one, you can look at your, I guess you needed the other sheet today too. Let me find my other sheet. I can't find mine. It doesn't matter. So what you really need to think about with this is you need to think about where negative 210 degrees is. If you use negative 210 degrees, you can kind of think about that to help you answer the question accurately. So if you think about your unit circle, if I have a unit circle and I have my initial side here, I know that 180 degrees is going to be right here, right? So 180 degrees is going to be right there. So that means if I go in the opposite direction this way, this would be negative 180. And then if I go 30 degrees more, this would take me to negative 210, right? So that angle right there is negative 210. Now, what I want you to kind of think about, because this is just a different method that you can take for this. It's not the only method that you can take for this. But if I have this angle right here, I'm asking about that value, right? That's my angle. I'm asking about what the tangent of that value is, which if you remember, we know that the tangent of something is equal to the cosine, the sine over cosine, right? So tangent is equal to sine over cosine, which is the same thing as y over x. So all I have to do is I have to find where negative 210 is on my sheet. And I can also pay attention to, I can use that value, the x's and y's, to figure out what the tangent actually is. There's another method that you can use if you'd like to do that way. You could also say, find the reference angle. Now, this is, again, something that we've talked about. You can use the reference angle to help you out with this, and that might be something that helps out in the future. So the reference angle is the shortest angle to x-axis. So it's the shortest angle to the x-axis. So if I look at this right here, this right here is the shortest angle to the x-axis, which is 30 degrees. So I could use the reference angle to help me out with that. Because if you look on your sheet, I'm looking at if you look at your unit circle, negative 210 shows up right here. You should see that. You should be able to find that. Negative 210 shows up right there. And the square 30 shows up right there. Those are the same distance away from the x-axis. So you could try to use the reference angle, but when you use the reference angle, you have to make sure you're paying attention to the appropriate quadrant. All right. So for some of you, this isn't going to be the best method, because in order to think about the quadrant, you have to think about the signs. Reference angle is a great idea if you're dealing in quadrant 1. So if you're in quadrant 1, use the reference angle as much as you want. If you're in a different quadrant, it might just be easier to go around and find out where that angle is actually located. Because if I'm looking at this spot right here, I can see that the x value is the negative square root of 3 over 2. And the y value is 1/2. I can figure out my tangent just plugging these in very quickly and very easily, right? I can do my sine over my cosine. And then I can do my copy dot flop, key change flip, whatever you call it. So 1/2 times 2 over the square root of 3, and this should be negative. So it's going to end up being negative 1 over the square root of 3. which is going to be the negative square root of 3 over 3. So my tangent value of this function looks like that. Now that being said, you could do the same exact thing using the reference angle. You could do the same exact thing by doing tangent of 30. But the tangent of 30, you're going to find out, is the square root of 3 over 3. It's going to end up being positive. That's because the tangent of 30 is not in the right quadrant. So if you look at the quadrant, and obviously this one happens in quadrant 2, I know that one of these values, x or y, is going to be negative, right? The x value is going to be negative. So since the x value is going to be negative and the y value is going to be positive, that would end up making this negative because one of them would be negative. So either sine or cosine, one would be negative. So that's because here, cosine equals negative and sine equals positive. And if you have a negative and a positive put together, it makes the whole thing negative. So it's just a different method, a different tool for your toolbox that you can use if you'd like to use that. Just kind of keep that in mind. Sometimes that helps, sometimes it doesn't. Sometimes it's a good idea, sometimes it's a bad idea. It really, it depends on what you're comfortable with solving. Okay. The very, very last thing I want to talk about, and it kind of wraps up what we did with the sine cosine value, is we can do something like this. If you are told theta is in quadrant 2, if you're told that theta is in quadrant 2, and then you know that sine of theta equals 1/3. Now, if you notice, there is no value in quadrant 2 that has a 1/3 on it, right? There's no value on your unit circle that has a 1/3 on it, which that's really tough. That is something that we don't really know how to do or how to solve if I'm supposed to keep this exact. So right now, this is the first instance that I would ask you to keep something exact, even though you don't know how to use your unit circle for this. So what I'm going to do is I'm asked, so theta is in quadrant 2, sine of theta equals 1/3. I'm going to ask you to find cosine. Oops. So I'm asking you to find cosine of theta. So there's a couple different things that you could do. Number one, you could draw a triangle. I know that this is quadrant 2, right? So I know if this is in quadrant 2, I could draw a triangle, which means that on my unit circle, this point is going to be somewhere up here. So I'm going to have to go left and up to make that triangle. So that's one option that you could do. So I would draw a triangle like this. Oh boy. Draw a triangle like that. Here is my angle, my opposite, and my hypotenuse, right? That's what that thing would look like. But now I have to pay attention to the cosine value. So this is my x value, but remember my x value is going to have to be negative because this is in quadrant 2. So if I want to, I could use the Pythagorean theorem to solve that way. So I could do x squared plus 1 squared equals 3 squared. So that would be x plus 1 equals 9. So then I would x squared plus 1 equals 9. So then I would get x squared equals 8. So I would get x equals the square root of 8. But now you have to really pay attention because this has to be negative. So it would end up being x equals the negative square root of 8 because I'm going in quadrant 2. So now if I wanted to find the cosine value, I would just say the negative square root of 8 over 3. All right. So if I have that, I could then simplify the top. The square root of 8 breaks down into the square root of 4 and the square root of 2. So I would get 2 square roots of 2. So this thing would break down to be negative 2 square roots of 2 over 3. So that was what the cosine is. That's one method. I don't know if that method is easier or harder, but it's just a method. The other thing that you could do is you could think back to what we talked about yesterday and find that we remember sine squared plus cosine squared equals 1. And if I know what sine is, I can plug that in. 1/3 squared plus cosine squared equals 1. So now I'm going to get 1/9 plus cosine squared. I'm going to subtract 1/9 from each side, so I'm going to get cosine squared of theta equals 8/9. Then I'm going to take the square root, and I end up with cosine of theta equals the square root of 8 over, and then the square root of 9 is 3, and that's exactly what we just had. But what you have to pay attention to is you have to remember what quadrant we're in. So this will, again, break down to 2 square roots of 2 over 3, but we have to remember what quadrant we're in. Since we're in quadrant 2, the cosine value has to be negative, so we have to remember to put that negative there. Your work will never, ever be able to produce that negative sign. You have to take this information to produce the negative sign on your own. So what I've done here is just 2 different ways to do the same exact problem. Some of you will choose to use this way because it makes more sense to you. Some of you will choose to use this way because it makes more sense to you. It does not matter at all how you solve this. I've just shown you 2 different methods to solve the same problem. All right? Do you guys have any questions or issues that you can think about right now? Any concerns or questions or anything that pops up as you're staring at it right now?
I'm confused. How is the radius 1 in this problem?
The radius is not 1 in this problem.
But I thought the...
You're saying for the sine squared plus cosine squared equals 1?
Yeah.
So remember, no matter what, it doesn't, trig value ratios do not change no matter what the circle is. So no matter what size the circle is, the statement sine squared plus cosine squared equals 1 will always be true, because regardless of how big the triangle or the circle or triangle or whatever you want to call it is, sine and cosine are just a ratio with each other. So since sine and cosine are only a ratio, that ratio holds true whether the circle has a radius of 1 or whether the circle has a radius of 10 billion. The ratio between sine and cosine holds true regardless of what size the circle is. Does that make sense? So no matter what size the circle is, no matter what size the triangle is, no matter what, the equation sine squared plus cosine squared equals 1 will always be true. You do not change the ratio for that. It is always sine squared plus cosine squared equals 1. That is the unit ratio for that. That is the ratio that will never ever change. It is always true, and it's one of the most powerful statements in trig. Sine squared plus cosine squared equals 1, because no matter what, regardless of what the ratio is, it is always going to be equal to that statement. All right, I'm going to stop recording right now so that I can stop rambling.